Yeah, good evening.
Yeah, so we are starting. I think the last time we did some loops and then we did strings and then few other things and then conditions and switch statements and we did some few examples with them. So today our next topic will be arrays. So today we are going to go through arrays in C++. So let's create our basic file as usual. So today we have part 4. So what we always do is we just create a simple hello world. So we say username space standard. Say username space and then we create our main function and we see out something. So let's say arrays C++. So let's compile this our code. So I think we already know how to do this because we already go through all these things. So at 4, then we compile, then we run it. 4. So we have our output. So our first topic for today is arrays. So let's start with arrays. So let's say what are arrays? So by definition, we say arrays are a fixed size collection of elements of what? Of elements of the same data type. As you all already know what a data type is. So we say we can access arrays using an index. Let me accept someone in the call. Let me change the call settings. I'm coming. I want it to be like this. I want anyone joining to just join directly instead of call control. Um, uh, where will I change the settings? Let's continue. Let's just continue. So we say we access what arrays what using what an index. So one I let me give some few example or advantages of using arrays. So we said some of the examples advantages of using arrays is they are efficient for random access. Like if you want to directly jump to any element in an array using an index, they are efficient for that. And then they are also what we call cache friendly. So elements, because the elements are stored continuously in the memory, they lead to faster access for sequential operations. When we say sequential operation, like line by line or step by step operations. So that's what we call sequential operations. So let's see some examples of or let me give some few disadvantages of arrays in C++. Some disadvantages include fixed size. So let's say, for example, once declared, the size cannot be changed during the program execution. And then we have another one, which is like when you are accessing arrays out of bounds or bounds, the bound bounds. Yeah, if you are accessing them out of bound, you get errors. Yeah. So that is just some few disadvantages of using arrays. So let's see some examples of how we can declare an array and then how we can use it. So to declare an array, let's create a simple array template here. So we have the data type, which will be array, the array name. Then we can here we can decide to add the array what size. So this is how we declare an array. This is how we declare an array. So I think that the last, or is it part two of the basis? I think um we did loops. So today we'll be using loops a lot in this array in this session. So we'll be using loops a lot. So we have two ways of declaring an array. One is you declare it, and then the other type is you declare and initialize. So for example, we can say type data type, then we say array name, array size, and then we just equal it to the elements. So this is another type. Uh, so let's see how we can declare some example of an array. So we say the data type, and you all already know what the data type is. So let's first declare an integer of array. For the array, we can give it any name. So if one, we can say points, and you can then we add what the array size. And there are two ways that we can give the array size. Either we 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 remove the size here and then what just initialize what the elements. or we give the size, and then initialize the element, or we just give the size and then initialize, assign the element later. So for this one, let's say we have an array of size 5, then we say it equals to this. So we have arrays they start from what, 0. So we have 0, 1, 2, 3, 4, 5. So this is an array of size 5. Okay, yeah. So let's say we want to get the elements of this array. So let's say we want to add all the arrays together. So we say int sum equals to 0. As you know how to I hope you know how to declare an integer variable. So we have a variable called sum, which is having the data type of int, and we assign it to 0. So we already did loop. So let's use the for loop to loop through this. So we define our index, let's say, which is index equals to 0, and we say index is less than what, 5. Then we say index what, plus plus. Then we increment the index. So here we say sum plus equals to. Then we have our points here. So this loop will start from what, 0 here. The loops will will first declare this variable here, index, and then we say the index should what, start from what, 0. And we say if the index is less than what, 5. If the index is less than 5, then what, break out of what, this loop, this for loop, and we keep what, in incrementing or increasing or adding one to what, this index. So it will start from 0, 1, 2, 3, 4, 5 in that order until it reaches 5, and then it will what, break out of the loop. So let's um, let's print out this and see. Let's print out this. So see out. Then we have some of points. Let's just say sum of points, and then we have got the points. So let's run this and see what we'll get. Let's run this. So we compile. Okay, we get an error. Too many initialized for int 5. So what we have to do is we have to remove one of this. And the reason why we get this error is because the size of the array, the elements in the array are more than the size of the array. So we have 1, 2, 3, 4, 5. So this should be what, equals to what, the size of what, the size of the array. But at first we added this, making it what, 6. So this will make it 6. 1, 2, 3, 4, 5, 6. So but if you remove this, then we'll make it 5. So that's why we get this error. Yeah. So let's compile again. You see, we don't have any error again. If we wanted, we would have leave the 5 to there, and the 5 here, and then make this one 6, and make the array size 6. If you compile, we'll still get the same distance. So it's either you increase the array size or you decrease what, the element. So let's run the compile code, and you see that we get the sum of the points to be what, 10. So let's see, if we add 0 plus 1, you get 1 plus 2, 3 plus 3, 6. Or yeah, so we just add them together, 1 plus 2 plus 3 plus 4 plus 5, and we get this. So we get 10 because if we increase this one to 6 here and we compile again, we get 10 because the 5 was not being added. So if we compile it and then add it again, we'll get what? 15. So now we are adding all these numbers. So 1 plus 2, 3, 1 plus 2, 3, plus 3, 6, plus 4, 10, plus 5, 15. So that's why we have 15. So here, if we increase, as I was saying, one of the disadvantages is trying to access um, a value that is out of bounds. For example, let's increase this to 7. Let's increase the index to 7 and try to compile. You see that it has compiled, but let's run the code and you see. So we get what? 21. But the array size is what? 6. But we are looping through more than what? That. So this is an example of a example of like how you can create errors within your code if you don't uh, keep an eye on your array sizes and look through them well, because you'll be getting what, like unexpected results from your code. So we are saying this one is 6. So we can say if less than or equals to 6 if you want. So for this, you always have to keep an eye on your code, and then what, be sure that okay, the arrays that I'm accessing, is it the same size as what the array that I declared before you access before you get what, arrays out of bounds, or maybe you get unexpected results from your compiler. Sometimes the compilers too are too intelligent that like some of the things they will catch them for you, or like resolve those issues for you without you knowing, and then the code will still run, which will what, leads to what, unexpected behavior in your code. Yeah. So um let's try the other way of declaring variables. That is this one, the second one here, this one, where we have we omit the size. So let's say we want to omit the size. So we say int array. So we omit the size and say equals to 0, 1, 2, 3, 4, 5. And then for this example, we are going to use, so let me bring this down here. Say on size omit, size omit. So for this example, we are going to use a while loop. So we say int I equals to 0. Someone mic was open. So let's say we declare this. We declare, because when you are using while loop, we have to initialize the index outside the while loop. So as we did the other time when we're learning loops. So we say I is less than. So let's count the size of the array. We have 1, 2, 3, 4, 5, 6. So we have 6. So we say I is less than 6. Let me make this one 5 so that people will not become confused with for this top one, that we make it 6, so that you know that these ones can change. So here let's print out let's print out let's say array, and then we print out what the index. So we say, let's say indexes index, and then we come here, we increment what I. So we increment, we have post and pre increment, like when you take the value and then you increment, or when you increment and then what, use the value. So for example, we use this value before what, we increment, we increase it here. This one we use the value and then we add, and this one we add and then use. So they have difference. Yeah. So let's compile this code and see what we'll get. So we get I was not declared in this scope, but we have I here, and we say I equals to 0. Let me see. I hope we are not out of. I didn't put, no, no. I'm coming in this. Someone want to join. Let me admit the person. So let's compile this again and see. I was not declared. I don't know why we are getting this error. Okay. Oh, sorry. Semicolon. I have to get this IntelliJ working so that some of these silly errors will try to avoid them. Because I didn't add the semicolon, this thing was just passing by. So let's compile it and then we see. So you see that we have what our indexes here. So we have 0, 1, 2, 3, 4. Now if we count 1, 2, 3, 4, 5. So we have what, this loop. So we are looping through this what, array, where we omit the size, what we call size omit. Then we loop through it and then print out what, the values. So let's see how we can use dual loop, because the other time when we were doing the loops we didn't do so much example, because I wanted to use this array as examples to show you how to use the loops to loop through them. So we say arrays with dual loop. After this, we also see some examples of how like we can use arrays in like game development, in the game, in respect to the game development side. So let's say arrays with dual loop. So here we can decide to um, create an array. So let's say array do. You can just call it array do and say it's equals to. So you can say it's equals to 14, 6, 8. Just inputting random numbers. So yeah. Then let's not forget our semicolon again, and then let's have int max. Let's say max equals to array 0 array underscore do. So here we are saying that this array we declare with the data type of integer should what take the first number of what this array or the first element. In array, when accessing the elements, 0 is the first one, so we say we should take what the first element. Because if you go to here this place where we define an array, we say array are fixed size collections. I forget to add this collection of elements of the same or data type, and we access arrays using what our index, and we say what they start with what they start from was 0. So we say index start from what 0. So the index of when you are accessing the elements of an array, the index start from what 0. So here that's what we are saying. So we say the maximum number is 0. So the the we are storing this one, which is what the maximum number, as you can go see 14. We are storing it in what 0. So here let's declare our looping number, which we already use I. So here we use j, and we say j equals to 1. You see the reason why we are using 1. We don't want it to start from the loop like on the first index, which is 14. We don't want it to start there. So here we say we should do this. So let's say do. Then we have if the array into bracket j is what greater than what max. Then we'll say what max equals to what array what j. So basically what we are doing here is we say if j, because we say here j is what equals to what 1. If j is greater than the maximum number that we declare here, which we say is what 14, then we should what reassign the maximum number to what that what index where we declare it as 1, and then the index 1 is what is equals to 6 here, as you can see. And then if you see 6 is not greater than 14, so this do while loop will not work. Then we will come here and say what we come to this and say increment what j. Then we'll come here and then we declare what the while loop. So while j is less than, let's count the values that we have here. We have 1, 2, 3, 4, 5. So while j is what less than what 5, and that's it. So we'll come here, let's print out the maximum number. So we say cout, and we say maximum. Let's just say maximum. How do they spell maximum numbers? Maximum elements in the array is, then we print out the maximum value. So let's run this and let's compile it. Okay, no error. Hopeful. Then we run it, and we see that we have what the maximum element in the array is what 14. Okay, because we said what it should be equals to what 14. Let me allow someone in the call. So we said what the maximum element in the array is 14. But let's say we decide to change this one to 16 and see what we'll get. So let's compile and link and then create our executable and we run it. We see that the maximum number now become what? 16. Okay, because we said we said that if what if we look through j and then the j is what greater than max, then we said that max should rather be equals to what? That index of j. So for example, let's change the last index to 100 and we compile our program again and we run. You see the max number become what? 100. So this is how you can simple what? Get the maximum number in an array. So we just say do this. If array, if the index of this array is greater, if this index, let's say the j index that we are what looping through is greater than the maximum what value we already defined here, then we should what reassign that value to what max. So 14, 16, 8, 12, then 100. 100 is the maximum value. So it's what assign it to max and then we get what 100. So it should loop through this while what j is what less than 5. So that is basically how we can use what do while loop with what arrays. So when we're doing the loop while we forget to add some other type of loop which we call the range base. We call it range based for loop system. Range based for loop. Oh, range based for loop. Or in other languages which we call for each. For each other languages is similar to the for each loop. Yeah. So down to what we can do is we can just declare a variable. So we just declare a variable. I'm coming. So let's declare a variable. Let's say, how will I call it? Int array underscore each range, or let's just say range. And this one will just as the same thing we do with the other distance. Let's just add some simple numbers here. Let's say 1, 20, 5, 6, 9. So here we have, let's make this one to 7. 5 is already there. Let's add 10, 12. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7, an array size of what? 7. So in order to use the for each or the loop, you can do it. This is how it's being declared. So we have our for loop, then we have the type, then we have the variable name, and then we have the array name, the array that we want to loop through name. Then we have our closing bracket, and then we have our code block. So this is our code block. So when we come here, let's give this one size because all of them we are not giving them size. So we have 1, 2, 3, 4, 5, 6, 7. So we have an array size of what, 7. So we just say 4, and we say what the first this thing is, the type variable name. So let's just say int I, because that's the type variable. And then we bring what, is it the parenthesis, the semicolon, this thing, and then we bring what, the array name, which is array range. And then we just what, put our block of code here, which will say cout I. So this one, let's add something so that it will be nice. So let's say uh, for each loop indexes, the index. So it will just start looping through this. In the end of it, return our end. So let's try compiling this and see what we get. Okay. We didn't get any error. So that's, you see that we have what, for each loop. So this, it will just print out this. So there's difference between, you see that this one is shorter, is somehow shorter than the for loop, the main for loop that we use here. What is it? This one. So instead of defining all this, you just come here and then you just say this. You just say okay, int I. We just define it and then we bring what the range and then we just print it out. Yeah. So this one is more simpler than the it's more simpler and then more straightforward than the normal for loop that we are used to. Okay, so let's, before we go deep into examples of how we can use arrays in game development, let's see how we can get the array size, the size of what, an array, because sometimes we may want to what, loop through an array with what, a specific type instead of just guessing the type and writing it manually. So let's just say how to get getting the size of array of an array. So getting the size of an array. So this one, to get the size of an array, let's define what an array. So let's say int array get, and also this name that I always define here, like these names. You see, I say array underscore get size here. You can make the name, like you can give any name that you want. As far as it's a valid C++ name, you can give it any name that you want. So this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 elements in the array, in this array. And then in C++, if you want to get the size of an array, first let's see like this example of how you can get the size of elements or maybe types, data types in an array. So let's just say size of this and see what we'll get. I want us to understand something before we move on. So let's print this. This is a valid word. So let's print this one. Array size. And then we end line. and this one. Let's see if it will compile. Do I spell the thing correct or not? Let me see. Array size. This. Oh, sorry. It says size. It's size. The size of an array. Size. Size. So let's compare this. We see that. Let me give space here so that you see it clearly. Let's compile again. You see that we get 40, but then the array size is 10, but it's giving us 40. The reason why we are getting 40 is because instead of 10 is because the array contain what? 10 elements. And then the size of operator always return the size of a type in what? Bytes. So this one is what? The byte. So we say, let's say this one is what? Array size in what? Bytes. So this, if you just do this, you are going to get um the byte, let's say byte, the array size in byte. But let's say we want the actual array size. So let's come here and say actually actual actual, how do they spell actual? Let me see. Okay, actual actual array size. So we want the actual array size. So in order to get the actual array size, we have to what? Divide the size of what in byte of what the array by what? The size. Oh, I don't know why I keep on writing the sized. So we have to what? Divide it by the array size with what? Let's say any element in the what array. Because we say what an array is a collection of what elements of what the same data type. If one would have put size of what integer here. So for example, if we kept integer here, int, so it will divide what this size by what? An integer. So let's run it and see. And you see that we get 10. So the actual size of it is 10. So we are dividing this one 40 by what? Integer. And then if you see the first part of this, we say where we were declaring data types, we said that integer is what? 4 bytes. So 40 divided by 4 is what? 10. So we get what? 10. So that's why we get the 10. But we can also do it what? This way. So instead of putting integer here, let's say this size was not an integer, maybe it was a string. Let's say this was a string, or this data type, the return type was a string or a character, or maybe a double, or like any other data type. So the best way to do is what? We can just put this and then get what? The first element of the array. So this way, whatever the type is of the array, it will give us what? It will still divide it and give us what? That what? Actual size. You see that we still get 10. So this is what recommended. So this is the best way to get it. So let's say recommended way of getting array size. So let's see how recommend. Okay, this is how it is spelled. So this is the recommended way of getting an array size. So let's go to a multi-dimensional array. multi-dimensional arrays. I think maybe we can extend the time to 1:30 because I think we still have so much to do, and then we already consume 1 hour already. So let's go to a multi-dimensional array. So multi-dimensional arrays. C++. So let's just give some simple definition of what multi-dimensional array is. So we say a multi-dimensional array is an array of what? Arrays. So it's just like an array within what? An array. You see? So so we say what is an array? What is an array? Multi-dimensional array is an array of arrays, or we can say that is like an array that's what that have nested what arrays. Okay, different arrays. So for example, let's say we want to do matrices multiplication. We want to add different matrices together. We want to declare a matrix, a matrix, a matrices. So the way we define multi-dimensional array is what first we bring the data type. It's just somehow similar to what the normal array, but this one we we will add another square brackets. So we say array name, and then we have this is the first array, and this is the second array. So this is arrays inside arrays, and it have to also be the same data type. So the definition of arrays still hold here. Yeah. And then each of these can have different sizes. So for example, we can have 3 here and have 6 here, which we can have 3 by 5. So 3 by 5 matrices. And we can even have more than that. Like we can have, instead of having only this, we can have this, and then we can have another one here, 6. So this one we are having like more than one dimension. So like we have like the first dimension here, which is which we can say 2 by 2, the second dimension, and then the second dimension, which is also 2 by 2. So we will see example of how we can declare all this and then print them out. So first let's go with the 2 by 2 here. So this one will be using let's use strings instead of this thing integer. So we said the last string, we say if you want to use string, we have to include it. So we just include string. Yeah, simple as that. Then we come here, let's define our string. So we say string, and then we have, let's say alphabet array. Then we say 2, by what? 4. So basically what this one is doing is that you see the first two here would declare the first size of the what? Array. So here we have what? 2, which we have this array followed by what? This array. So this is what we are doing. So 2 here indicate shows that we are having what? 2 arrays inside what? This array. Okay, so the 2 here indicate that we are having 2 arrays inside what? This array. And then the 4 here indicate what? The elements in what? Each of this array. So the first one, we should have 4 elements. So we can have we can have 4 elements. So 1, 2, 3, 4. Let's remove the e. So this is what? The first array, and we have what? 4 elements. It must be what? 4. That's what we identify. Then the second element, we said what? It should also what? Take 4, which we have e, f, g, and then h. So basically we define what? 2 arrays inside what? 1 array. So these are the 2 arrays, and we say inside each of the 2 arrays, the elements must have the size of what? 4 inside these arrays. So that's what we just did. So inside we declare array a multi-dimensional array of 2, and then inside each of the arrays it should have what? 4 elements each. 4 elements each. So that's basically how you can define. Then the third one, which we can have like three numbers. So let's say string, and you can just say try. I'm saying try because it's three. Try alpha, and then we say array. So here we can have, let's say 2, 2, and then we can have 3, and then we equals to 3. So this one too, we have what? We have 2 arrays, and inside the 2 arrays we have what? Another 2 arrays. Then inside the another 2 arrays, we say the element should be what? 3 elements. So first, let's define what? Our first array. This is our first array, and this is our second array. Okay, let me format this and it will look nice. Yeah. So we have first array and second array. That is what corresponding to this first two. This first two here. Okay. So we have 1, 2. Or let me make this one. Let me make it. Let me make it 4, so that you understand it very well. We have here 1, 3. That's 3. And we have another one here. Let me just quickly resolve this spelling error. So we say 4 elements. So the first array, we are taking 4 elements here, which are types of what? Arrays. So 4 elements array. So we have 1, 2, 3, 4. And then inside this element of array, we say we want what? Another 2 arrays inside this. So inside each of them, we what? Define another what? 2 arrays. So this one 2. Then we come inside this one 2, and what? We define another 2 here. and then we come to this guy too, and we define another 2 here, and then we come to this side too, and we define another 2 here. So inside each of these 4 elements, 1, 2, 3, 4, we are having what 2 arrays inside each of them, which are 1, 2, 1, 2, 1, 2, 1, 2. And now the last array is what? The last element is like inside each of those arrays we should have what? 3 elements. So for example here you can say element 1, element 2, and then here too we can say 4, element 5, element 6, and then inside this one too we can have 7, 8, 9, and then this one too we can have 10. I'm just using the numbers for us to understand, but you can put any element here because it's a string. A string can be anything. Yeah. So let's say 10, 11, and then you have 12, and then this one too we have 13, 14, 15, 16, 17, then 18. Then the last but not the least array, we have 19, and then we have 20, 21, and then the last one we have 20, 22, 23, and then 24. So here this is it. So we have what different what arrays. I'm trying to make this thing look, the format look nicer. Yeah, something like this. Yeah. So we have what the first array here. Then this is the first array. Then we have, let's say this is the first one. This, we have the second one, the third one, and then what? The fourth one. So let's bring this one down. Let's bring this thing down here so that you get, you see the draw the this thing clear. So you see it clear. So we have the first array. 1, 2, 3, 4. So we have four arrays here. Then add this thing so that if you see it clear, this one belongs to this one here. And then we say 4. So after that, inside this 4, we say each of them should have 2. So each of them is having what? 2 arrays. 1 and 2. And then we say inside that 2 array, each of them should have 3 elements. So we have 1, 2, 3 inside each of them. So that is basically how you can declare multidimensional arrays. Mostly when you are doing matrices calculations, this is what we will use. So let's say if you want to access elements. So if you want to access element in this multidimensional array, so let's use the first one for example. So we say cout elements multidimensional, and then we can say aph. So this is how we can access the element. So if we compare this and run, let's compare this and then we run it, you see that we get a here, element in multidimensional array. You see that we get a. The reason why we get a is because we said what, the first array, we have two arrays here. We say the first one, which is this, we should what, take that one, which is this first one, then take the first element of what, that array, that first array, which is what, a. So if we want b, we have to put where 1, and then we what, we compile again and run. You see we get b. But let's say we want e, so we have to put 1 here and then what, send this one to a 0. We compile and we get what, e. So basically that's how we can access what, element within those kind of, within multidimensional array. So let's see how we can access element in this three-dimensional array. So this one too, if we want one, this is how we do it. So we compile and we run. Okay, oh, let me change the name. Sorry. Let me change the name here, TR alpha. Yeah. So we change the name. We are using the three-dimensional one, and you see that we get 1 here. We are getting 1 because we are accessing the first array. There are 4 arrays within this array, and we are accessing the first one. And then in the first one, we are taking what, the first array of the first array. I know you may become confused, but we are saying we are getting the first array of what, the first array, and then inside that first array of the first array, we are getting what,